Hi everyone. I hope everyone is doing fine. So our next chapter which we are going to start is your chemical kinetics. We're going to start about chemical kinetics. What do you mean by kinetics? Kinetics means the rate, right? In this mainly we will study what is the rate of the reaction. Rate of the reaction means, like, suppose you are doing a reaction, A plus B is giving you C. Now, in this particular chapter, you will study what is the rate, how fast it is going, what is the stability of the product. So, chemical kinetics is a branch of chemistry, branch of physical chemistry. It is a branch of physical chemistry which deals with your rate of reaction. Second thing which we need to study is factors on which rate of reaction depends. Factors on which rate of reaction depends. The third thing which we need to study is the mechanism of the reaction. Mechanism of the reaction. Okay, mostly we will study about your rate of reaction, your factors of rate of reaction. In factors, you will get lot of things like temperature, your coefficient, okay? Your temperature, concentration, temperature, and your concentration and all. And in this concentration terms only, we'll be studying about your first, second, third order reaction, nth order reaction, and your zero order reaction. In temperature, we'll come across the topic of Arrhenius equation. Then we'll study about your rate law and then your molecularity, and then we'll study about the mechanism of reaction. So these are the three major topics which we need to cover along with your molecularity. So let us start with the first topic of rate of reaction. Our first topic is rate of reaction, also represented as ROR. See, any kind of reaction is happening, like A plus B is giving you C. What is a major goal? To get the products, right? So, the reactant concentration, these are your reactants on the left hand side, right? The reactant concentration will decrease with time and your product concentration will increase with time, right? So, what is rate of reaction? It is the, like, by definition, it is called as, it is change in concentration. Change in concentration. It is the change in concentration of reactant or your product with respect to time. How much change has happened, that is called as your rate of reaction with respect to time. Now there are various kind of reactions, right? Like some reactions happens very fast. Some reaction happens very fast, like for example your ionic reactions. Ionic reactions happens very fast. For example, your NaCl plus AgNO3 is giving you AgCl, which comes in PPT, plus your NaNO3. This reaction, this particular reaction and various other ionic reactions happens very fast. Now this particular reaction happens in 10 to the power minus 6 seconds. So for these kind of reactions, it's practically impossible. ROR cannot be determined. Rate of reaction cannot be determined because you're not getting that time only to see how much concentration of the reactant or product is changing with respect to time. So rate of reaction cannot be determined practically in this case. Rate of reaction cannot be determined practically. Second kind of reaction which you have is very slow reactions. Very slow. Like for example, you take rusting of iron. Rusting of iron takes years to rust, right? Rusting of iron. Fe is your iron. It takes many years to rust, right? You don't have that much time. You don't have that much tools to check how much concentration is decreasing with respective time. So that's why ROR here also cannot be determined. ROR cannot be determined here also. Then the third type of reaction which comes is your moderate reactions. Third kind of reaction which comes is your moderate reactions. What is moderate reaction? Example, N2 plus 3H2, like just an example. N2 plus 3H2 is giving you ammonia. Ammonia is 2NH3. What basically happens in your reactions? Some bonds are breaking and some bonds are forming, right? Sorry, H2. Bond breaking and bond formation. These bonds are breaking and some new bonds are forming. These kind of reactions only gives us the rate of reaction. Only in these kind of reaction you can practically determine the rate of the reaction. Okay, so what is the rate of reaction? Rate of reaction is something we determine the change in concentration of reactant or product with respect to time. Three kinds of reaction: very fast, slow and moderate. We can only determine the rate of reaction for for moderate reactions. Okay, now there are two kinds of rate of reactions. One is instantaneous and one is the average rate of reactions. Let us study how do we write. Like this is very important. Once you get to know how to write the average rate of reactions, all the questions will become very easy. For example, just learn the first one. Okay, 2A plus 3B. I'm writing my average rate of reaction is giving me 4C. How will I write my average rate of reaction? Average rate of reaction. What I'll do is, I will be writing delta A by delta T, right? Delta A by delta T. Why delta? Change in concentration. What is concentration? Change in concentration per unit time. That's what we are measuring, right? Delta A by delta T. What is the coefficient here? 2, right? So the coefficient is coming in the denominator. And A is the reactant. A and B are the reactants, right? And its concentration is decreasing. So whatever is decreasing, reactants concentration is decreasing, product concentration is increasing. So since the reaction, like the concentration is decreasing, we'll put a minus sign. This is how you find the average rate of reaction, which is also equal to, now can you write the average rate of reaction with respect to B? We'll write it delta B by delta T, not necessary to write T on brackets. What is the coefficient of B? 1 by 3. And since this is decreasing, this concentration is decreasing, we'll write a negative sign. Then how will you write in terms of C? Delta C by delta T. What is the coefficient? 4. 4 will come in the bottom. Here we won't write minus but we'll write plus. Why are we writing minus here? Because the concentration of reactant is decreasing. Whatever our reactant, will write minus. Concentration of reactants are decreasing. We are writing plus here. Why? Because the concentration of product is increasing. Okay. One more example I'll give you guys. Just try it on your own if possible. 3x plus y is giving you 2z. How, just pause this video and try it on your own. How will you write the average rate of reaction in terms of x, y and z? Try it on your own and let's check our answers. Average rate of reaction. First we'll write it in terms of x. What will we get? Change in concentration, delta x by delta T. And 3 will come in the coefficient 1 by 3. So minus 1 by 3. Which is equal to your delta y by delta T. What is the coefficient here? 1 only, right? So 1 by 1. And with the coefficient of minus. If you don't write 1 by 1 also, that's fine. Then in terms of Z, what will be the change? Delta Z by delta T. What's the coefficient here? 2. So 1 by 2, and here the sign will be plus because this is the product, and reactant will write the minus sign. This is how you write the average rate of reaction in terms of delta. Delta means change. Okay. Next thing is, okay, well, let's study it here only. Next thing is rate of appearance. Rate of reaction, how do we write? You have got it, right? Next thing is your rate of appearance, which is also called as ROA, rate of appearance. What is rate of appearance? What thing is appearing? Your product is only appearing, right? Because reactants are decreasing, reactants are disappearing. So rate of appearance, you'll write it as ROA. And how will you calculate it? Like for this, for example, for this reaction, rate of appearance will be equal to your delta C. Same thing you're writing, delta C by delta T. But here you are not going to write any sign and just put a mod here. No role of positive, negative and your stoichiometry. So just write it here, no role of your positive, negative and your stoichiometry. This is how you write the rate of appearance. Similarly, you can write the rate of disappearance as well. What will be your rate of disappearance? The rate of disappearance here will be, what is disappearing? Your reactants are disappearing, right? So you can write it in the form of A for first one, delta A by delta T in the form of mod. No positive, no negatives and no stoichiometry. Similarly, you can write it for delta B also, delta B by delta T. That's your rate of disappearance. Okay, so 3 things we have studied: rate of reaction, rate of appearance and rate of disappearance. Rate of reaction, put the concentration by time, write the stoichiometry along with signs. Rate of appearance and rate of disappearance, no need to write the signs of it. Okay. Now, what will be the unit? Major thing. What will be the unit? Unit of rate of reaction. What was rate of reaction? Change in concentration per unit time, right? Change in concentration per unit time. What is concentration? Moles per liter. Similar to molarity, right? What is concentration? Molarity only. So that is moles per liter into your time. Correct? Time is measured in seconds. So what will be our unit of ROR? Moles, liter inverse and second inverse will be your unit of ROR, moles per liter. Now in case of gases, you are taking ATM, right? Pressure unit, we take pressure unit, so that thing will be ATM. Here it will be ATM, pressure per time, ATM per second inverse. Okay, now we'll do some questions for rate of reaction. Okay, I have one question for you where you need to write the average rate of reaction. Write the average rate of reaction. What is your reaction given? 4NH3 plus your 5 oxygen is giving you 4NO plus your 6H2O. So what will be your rate of reaction? Your rate of reaction will be, these are reactants, these are products. So average rate of reaction or your rate of reaction will be equal to, in terms of NH3, what will it be? Delta NH3 by delta T and what is the coefficient here? 1 by 4 with a negative sign because it's a reactant, will be equal to, in terms of oxygen, what will you write? delta O2 divided by delta T, and this is equal to minus 1 by 5. 5 in the coefficient, minus because it's a reactant. Now we are coming to product. This will be equal to delta NO by delta T, and what is the coefficient for 1, and positive sign only because it's a product. Then in terms of H2O, delta H2O divided by delta T is upon 1 by 6 because 6 is a coefficient, with a positive sign because it's a product. This was our first part, okay, to write the rate of reaction. Second time it's asking, what is the rate of appearance of NO? What will be the rate of appearance of NO? Same thing, but without any coefficient, without any sign, and with a mod. So it will be delta NO by delta T with a mod. That's your rate of appearance of NO. Third question, write on your own. They are asking, what is the rate of disappearance of oxygen? What is the rate of disappearance of oxygen? So what will it be? Same things only, delta O2 by delta T in the mod fashion. That is your rate of disappearance of oxygen. No stoichiometry and no signs. Okay. So you can just write it down or take a screenshot. I'll just wait for some time. Okay, so let's do one thing. We'll do more questions in the next video. So just practice this thing, and we'll meet in the next video for more questions and factors affecting ROR. Thank you so much.